Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left side of your screen. Today's webinar, 3 Secrets to Driving Your Mainframe Success in 2018, is sponsored by BMC Software. Our featured speakers today are Jeremy Hamilton and Wayne Wilson. Jeremy is a Senior Product Manager for BMC's Mainframe Cost Optimization Suite. He has over 10 years' experience in the software industry, primarily in technical customer-facing roles. In his current role, Jeremy works to gather input from current and future customers to drive needed requirements into the cost management solutions. Wayne Wilson is a field software consultant with over 35 years of experience in IT. He has been a BMC software specialist in systems management tools for over 20 years and is also a BMC certified mainframe cost optimization specialist. Today, Jeremy and Wayne will share how it's possible to reduce your monthly licensing costs while increasing service levels. The two are not mutually exclusive. So with our introductions complete, Jeremy, I'll turn the presentation over to you.
Thank you, and welcome to the presentation today. Today, along with Wayne, as was mentioned, we'll be showing you how you can pay less for your mainframe tax, which we all affectionately know as monthly license charges. For most of us, this is the dreaded tax season, and we have to account for all the earnings and deductions over the past year. Unfortunately, sometimes we're made aware of how much we truly do pay. For mainframe shops, this kind of accounting happens once a month in the form of monthly license charges. Our latest survey of mainframe shops around the world showed that optimizing and reducing costs was the top priority for the coming year. And this has been a common theme in the surveys since it has remained one of the top 4 items year after year since the survey was introduced. But each year it gets tougher as new workloads move to the mainframe, higher SLA demands, and IBM raising the MLC costs 4 to 7% year over year. The fact is, most like taxes, MLC isn't easy to calculate or even understand how to optimize. So we have 3 secrets to share with you today. The first is how MLC is really calculated. Then we'll allow Wayne to take you through an intelligent phased approach to managing MLC. And lastly, I'll come back to share with you some insight on IBM's latest MLC pricing models, country multiplex pricing, and container-based pricing. So let's get started. To understand how MLC software pricing works, it's first important to understand the difference between full capacity and subcapacity. Full capacity pricing would mean that you are charged for software based on the full capacity of your machine. So if your box with 1,000 MSUs, then the software running there will be charged for 1,000 MSUs of usage. Subcapacity pricing is where software is charged based on a peak MSU contribution instead of the full capacity, with the key metric being this thing called the peak 4-hour rolling average. While the 4-hour rolling average metric is utilization-based, calculating MLC is not. If it was, then it would simply be the number of MSUs that a product consumes times the price per MSU would equal your bill. But if you've been around the mainframe very long, you understand that that is simply not the case. So let's examine the rolling 4-hour average metric a little further. Every hour on the mainframe has an MSU utilization value. So the first piece is to calculate the average MSU utilization value over 4 consecutive hours. That gives you a 4-hour average. That average is then calculated for each hour interval within a month. Since it's the peak value we're interested in, we look for where our utilization is the highest, In this example, that occurs at the end of the month. If we expand this view out, we can then calculate the rolling 4-hour average for each interval. And we see that our rolling 4-hour average peak value is at 704. Not exactly happy that I'm taking the peak value, but nonetheless, now I have a metric to work with. Now, in a simple world, this equation would be easy. We'd simply multiply the MSU utilizations by each product at the peak times their cost per MSU to calculate our MLC total. But this is the world of subcapacity pricing, and that means the peak value is actually applied to all the products running in the peak. So 704 MSUs for ZOS, 704 for CACS, and on down the list, which brings our total to nearly 6 times the utilization-based price. Where it starts to seem really unfair is when we look at the cost distribution. Because of the cost per MSU for IMS, even though it only contributed 11% of the MSU utilization, it makes up 29% of the overall cost. No matter how big or small the contributions are, they're all guilty of running during the peak and will be charged accordingly. In my days of working with clients, I've only worked with a couple that only had one LPAR, and most had at least 2 LPARs. And some even have hundreds. Each LPAR you add actually makes the equation more complex. So here's an example with 2 LPARs. The first LPAR is the one we were looking at with a peak at 704. The second, we calculated the peak to be at 760, but they're at different times. For MLC calculations, it's actually the combined peak or stacked value for the LPARs that will make up the MSUs used to calculate the software cost. So for this example, ZOS, CACS, and DB2 and some other software are running on both LPARs, and so they're charged at the combined peak value. But now if you look at IMS, it still has a value of 704. That's because it was only running on LPAR 1. So for MLC, you have to worry about LPAR peaks, product peaks, combined peaks, and 4-hour rolling averages. Your ability to know where and when to apply cost optimization efforts is difficult, to say the least. That, plus you have to wait a month or 2 before your bill comes back from IBM to see if the actions were effective. Trial and error is costly, and without a proper approach, MLC can be difficult beast to tame. That leads us to secret number 2, and Wayne will now walk us through a phased approach to managing MLC.
All right, thank you, Jeremy. Well, as Jeremy has illustrated, I think, fairly clearly, understanding MLC is really an important aspect of being able to manage your MLC in the first place. But really understanding it is just kind of the first step of it. And if you're going to be managing your MLC on an ongoing basis, what we recommend here at BMC is that you take a very organized and phased approach to looking at the whole process and being able to take some action that goes along with it. And that really comes down into what we call 5 phases of MLC. Now, the first phase that we talk about is what we call cost transparency. And as it says here on the screen, cost transparency is the foundation for having success. And cost transparency means really understanding exactly what it is that you're paying for each of your individual MLC products. The next thing that you want to do is, once you understand exactly what it is you're paying for the individual products, which ones, again, are going to be costing you the most and the least and that sort of stuff, is to analyze those 4-hour rolling average peaks that Jeremy just talked about. Because what's happening in the peaks is really what's driving the cost of the individual product. So if you understand exactly what's happening in the peaks, then you're going to understand exactly what it is that's causing those peaks to rise so high and give you the opportunity to do some management against those peaks. That takes us into the third phase. And the third phase, of course, is to manage those peaks on an active basis and to try and bring those peaks down in terms of what the used MSU capacity is going to be. And, of course, the result is going to be to reduce that MLC bill. The fourth phase that we like to talk about here is really managing the budget, because what you need to do, of course, is to not only be able to manage the MLC that you're being charged, but to manage that against your budget, because obviously we're in the business of making money, and just on all of the organizations that we work with. But of course, the whole idea is to reduce those costs and of course increase the profitability of the corporations that we work for. So being able to compare the MLC charges that we're managing against the budget that we are planning on paying certainly gives you the goal that you're going to be working with when in overall you're going to be managing your MLC bill. And finally, and this is something here that's probably not talked about all that much, is tracking your optimization successes. Because one of the things that we tend to do in the IT industry here today is that we tend to just do our jobs, do a really good job, but we don't tend to talk about it a whole heck of a lot. So it's really important to be able to track the successes that we're having in managing the MLC and make sure that our management is aware of the kinds of work that we're doing in order to achieve the successes that are associated with those organizations. So let me go ahead and dig down into that just a little bit deeper, and we'll talk about the individual components of the individual phases. I talked about cost transparency, and of course this is very, very key, as I said, to the entire process, because every organization that we work with here at BMC is paying millions and millions of dollars in MLC. That's an awful lot of money, and it is very, very worthwhile to be managing your MLC and be driving down those charges. And of course, if you don't have cost transparency, then there's really no point in trying to optimize what it is that you're trying to do in the first place. I mean, how can you actually measure your optimization efforts if you don't have transparency? And when I talked about transparency, one of the things I talked about is understanding exactly what it is that you're paying for the individual products. Now, BMC does a lot of work with a fellow by the name of David Wilson. David is actually one of the IBM executives who created the entire MLC process to begin with. He's an independent consultant today, and one of the things that we asked him about is what types of things should customers be looking at. And what David has told us is that the best cost models gives you the capability of calculating the actual cost of MLC, not only by individual product, but by feature, by the price tracks, by the incremental cost of the products. In other words, what MSU level are you working with today, and what is the average cost that you're paying? Give you some very detailed information on what the cost of the individual products are going to be. He says you'd just be able to track your monthly costs and compare that to the budget. I talked about that a little bit earlier. I'll talk about that a little bit more later today. You need to track that against your caps, against your budget, to understand and be able to advertise what's going on so that you know exactly what you're paying and that your corporation is aware that MLC is a very large component of the entire IT budget and what we're doing in order to manage those costs. And finally, on a monthly basis, when you receive your invoice from IBM, have the capability of being able to audit that invoice, because mistakes can be made. And I'll show you some examples of that as we go through a little bit further in talking about MLC. Knowing costs intimately by product really means being able to drill down on your MLC bill and to understand exactly what it's going to be. Now, ideally, it would be a good idea to be able to look at that even before you gain your invoice. And one of the things that we recommend here at BMC is that you have something in place that gives you the capability of modeling what your MLC costs are going to be even before you receive that bill from IBM. That way you're going to know ahead of time what it's going to be and how you're doing against your monthly budget for that MLC. But we also need to be able to, to drill down into what's driving all of those costs. For instance, being able to understand, is it a lot of low importance work in the peak that is driving that MLC bill? Is it a particular workload that's being driven by a business application that's running in your system? You need to be able to drill down on that sort of stuff. Can we group things according to things like WLM, service classes, WLM report classes, and you have all of the information that allows you to drill down and to understand exactly what it is that's driving that 4-hour rolling average and is driving your MLC peak? And of course, we need to drill down into a very, very low level of detail. So for instance, if it was low importance work that was driving that MLC in the first place, what was that low importance work running from? Was it batch? Was it a bunch of low importance CICS transactions? How far again can we drill down into it? And in this case, we're seeing that a very good component of that low importance work was batch workload. But we need to drill down even further into the detail and take it right down to the job level of information. And if we can have that kind of information at our fingertips, now we have the power to be able to drive change and to be able to reduce that MLC bill. We at BMC refer to this as kind of a way that we'll talk. We call that R4B4. What that means is to understand and analyze your rolling 4-hour rolling average, before you take certain steps. For instance, before you pay your MLC bill, understand why it is that that bill was what it was. Understand it before moving to country multiplex pricing or other pricing models. Jeremy will talk about that a little bit further, but it's real important to try and get your current MLC bill down as low as possible before you move to some of those other pricing models. It's also important to do that R4B4 before upgrading or migrating your MLC software someplace else onto new machines, as it were. For instance, if you're dealing with a company that is working on mergers and you're bringing in new organizations and new workloads, it's important, again, R4B4. It's important to look at that before moving workloads onto or off of the mainframe. I'll give you a little story. I deal with a number of different customers who even today are talking about migrating their workloads off of the mainframe. The fact of the matter is people say that the mainframe costs too much sometimes. But if you R4B4, it could be that the workloads that you're talking about moving off of the mainframe are actually less expensive on the mainframe than they are by moving to a distributed system. So if you R4B4, you might be avoiding a costly business mistake. And finally, R4B4 before your next IBM contract negotiation. Because if your bill is as low as possible, it gives you the power in order to negotiate better terms in the next IBM contract when you understand exactly what it is that's driving that bill. So understanding cost transparency, as I said, is the first phase to being able to go through and manage all of your costs. Understanding what those costs are is the very first step, because that takes us into the very next phase. And that next phase is analyzing the peaks very, very deeply in order to make decisions. Now, when we talk about managing the peaks or analyzing the peaks, we talk about focusing on what those key MLC cost drivers happen to be. And when we do understand that one, because remember, those numbers are the basis for the MLC that you're paying. The MLC bill, that peak 4-hour rolling average, remember, as Jeremy said, is the combination of all workloads that are running simultaneously, and those are the workloads that are driving the peak. And a detailed understanding of those drivers enables you to make informed and useful business decisions. This is an iterative process that you will be going through. And the more you work at this, the better you get. Now, Jeremy and I have been working at this thing for several years now, and we have an awful lot of fun working with our customers to go through this entire process and to show them what is driving their MLC bill. You can make a decision, make some changes, and then come back and start working on what the next most important one happens to be. So what are the types of things that you might want to look for? And I'm going to go through these kind of briefly. First of all, the things that we look for is anomalies. Most people are aware these days that there is such a thing as the exclude parameter in the SCRT reporting process. Exclude simply says that if you can identify some abnormal work, for instance, looping jobs or runaway jobs, things that don't ordinarily happen in your business processes, you can put an exclude parameter into your SCRT reporting, and IBM in about 90% of the cases will accept that exclude parameter and immediately reduce the bill that you would have been paying to IBM. So that's an important one to look for. Another one that's kind of important to look for is, are you paying for unnecessary MLC products? Now, some examples of that, and we've run into this on a number of different occasions, is people who are paying for things and running things like the COBOL or PLI compilers that are already running on production systems. Now, in most cases, companies will say they don't really want you to be doing compilations for programs on your production systems. You want to keep those on test or development systems. But we do still run into customers who actually have those compilers running, and all it takes is one person to run a compile on a production system, and you're going to be paying for that COBOL or PLI compiler for the entire workload of everything that's running in your production environment. So look for those MLC products and try and take them off of those systems. Another example is GDDM. Okay, that's the graphic display manager, which actually used to, at one point was used to create high-resolution graphics on 3270 terminals. Not too many people actually run those anymore, so that's something also to take a look at. There's also some flat-based IBM program products that would be based on things like, for instance, the printer and display facility. That's based on the number of printers that you have out there. Now, if you don't keep track of those number of printers, you're going to be paying for things that you don't necessarily need to be looking for. So look for those and see what it is that you're going to be paying for in the first place. There are also a lot of different products that are out there in the marketplace today. BMC would be very happy to go through and help you identify some of those things, where the products that you're running can be more efficient themselves, or you can replace products that are out there that tend to be very high CPU users. And if you replace those and use more cost-effective places, so those in turn will reduce that MSU consumption, your peak 4-hour rolling average, and reduce those MLC costs. Finally, the thing to look for, the key things to see, is take a look at those workloads. Do you have batch that's running unnecessarily in the peak, or particular applications that don't have to be running at that particular time? Can you spread them out? How about database utilities? That's another one to take a look at. And we've talked about it. We'll talk a lot more about things like running low priority work and how to eliminate the low priority work that happens to be in the peak. And of course, what we've always been looking for from a number of years now is continue and always to be looking for zip eligible work. Do you have enough zip processors to be managing that amount of work? Can you increase those and offload that amount of work onto zip processors? So those are just some key things to take a look for. And what I'm going to do now is just show you some examples of what those might look like if you're going to be managing them using a tool such as what BMC provides in our cost analyzer type of a product. I talked about the excludes and the anomaly situations. This is an example of a real environment where we had the customer who was looking at his data and he realized, wait a minute, this is a relatively small system that we're looking at here. Again, his peak 4-hour rolling average was 215 MSUs. But you notice what's happening here. On a Friday, all of a sudden his workload peaked very, very high, and it ran high right across the weekend. And you notice that the gap in the middle, they actually IPL'd in the middle of the weekend, brought it back up, and the problem was still there. And it wasn't until Monday morning where somebody realized what the problem was that was causing these workloads to run amok and using up all the CPU capacity they had. This is a classic example of an exclude kind of a situation. You notice that the secondary peak, just to the left of where that red arrow is, was running at about 180 MSUs. So what he was able to do in this case was to put an exclude parameter in place, and he dropped that workload, that peak, from 258 MSUs down to about 180. And that was, for him, was a significant reduction in the MLC that he was paid for. So it's really a good idea to look at this on a regular basis and prepare for and use that exclude parameter. I mentioned GDDM a little bit earlier, the graphic display manager that gives you the high-resolution graphics on a 3270 terminal. Most people don't use that today. As a matter of fact, I think there's just a couple of other very small vendor products out there that actually like to use GDDM anymore in the world. So if you have GDDM, be aware that you're running it. It's a very quick thing to do if you're not using it anymore, simply to de-license it. It's not a whole lot of money in your total MLC bill, but every dollar is another dollar that you could be saving in terms of MLC. What else to look for? I talked about batch. If you know your batch workloads, what address spaces are currently running in their peak, and you understand exactly how much they contribute to MLC, what that gives you is the opportunity to be able to focus on the highest consumers, and if you be able to identify the ones that you might be able to talk to your application people and say, is it possible for us to run this at a different time so it comes out of the peak? Now, there's an awful lot of them out there, and each one individually contributes a small amount to the total MLC. The one that I have an example here shows the 4-hour rolling average where this batch job ran, and you can see that this is one batch job that contributed $1,340 to a single month's worth of MLC. Now, on the other hand, if you do the math on that thing very quickly, if you had 10 of those jobs, that would end up being $13,000 that you could be running. If you had 100 of those things, that could be $130,000 that you'd be saving simply by being able to reschedule low importance work that doesn't necessarily need to be running in the peak. The other thing to look at is tuning those particular jobs. There's a lot of tools out there in the marketplace today that allow you to look at your batch jobs, see what it is that they're doing, and to be able to tune them for CPU utilization. So if they have to run in the peak, but you can tune them down, you can reduce their contribution to that MLC peak. And one of the things that we truly recommend that you do is particularly those jobs that are running DB2 in batch. Very, very frequently, the SQL that is running with DB2 can be tuned for much lower CPU utilization, and of course the result is going to be lower MLC. What else can we look for? Database utilities. I talked about that a little bit earlier, and one of the things that I like to point out to customers is, remember, MLC is typically being charged on a CPC basis. That means all LPARs that are running on that box. Now, in most cases, people not only have production LPARs, which is where your most important work is running, but you also have test and development LPARs. And remember, those test and development LPARs also contribute to the MSU contribution that is driving that 4-hour rolling average. So look at those test and development LPARs. What's running on those? In many cases, we find that people saying, hey, it's no problem for me to go ahead and run my DB2 reorgs overnight on my test and development LPARs. Well, if that happens to coincide with your peak 4-hour rolling average, that means that all you're doing is running database utilities in the peak. If you can reschedule those reorgs to be running at a different time other than the peak, again, you can reduce that MLC. What else? Low importance work. That's one of the key ones that we're looking for. Really, are you still running a lot of low importance work in the peak? Can it be moved, or more importantly, are you taking advantage of the capping capabilities that are available from IBM? Be very, very careful about your WLM importance classifications. If you have good ones out there to begin with, then you have a great opportunity to be capping the low importance work. And remember, capping doesn't mean we're stopping things from running. It simply says we can delay the low importance work to run at another time that's a little bit outside of our peaks. And I'll talk about that a little bit more later. So in summary, when I say we analyze the peak, remember, it's extremely important to dig deep into what's actually running in the peak, because that is the next step in managing the MLC. And the fact of the matter is, and I think you probably saw with some of the things I've just pointed out, that there's a lot of very easy gains that can be made by focusing on the various different things that are running there, because if it's unnecessary in the peak, take it out and reduce that MLC bill. So let's talk a little bit about managing the peaks. I talked a bit about how this, again, is an iterative approach. You can take one thing at a time and make some incremental changes to what's going on. I've talked about tuning workloads. I've talked about moving workloads, but I'm going to focus a little bit on a couple of things. First of all, let's talk about capping. A lot of people have looked at capping as being a way to go ahead and reduce your MLC bill. Now, in many cases, you will find that there's an awful lot of work out there that can be running in low importance work. And again, having visibility into what's out there will give you an idea about how much there is that you can possibly gain by being able to cap the low importance work. This obviously is a fairly extreme example where we see a customer who's driving an awful lot of very low importance work in the peak. In fact, in his case, it's about 2/3 of his work is classified as low importance. Now, there's a good possibility that you can cap quite a bit of this work. There's also a good possibility of looking at your WLM classifications to make sure that all of the work that is running here truly is low importance work that needs to be capped. Now, IBM has a number of different ways that you can do that. You can use defined capacities on individual LPARs, which sets a limit for that particular LPAR on what it's going to be, and you can manage that to the 4-hour rolling average, or you can use group capping capabilities working with IBM. They're very good ways of doing things, but they do have their limitations as well. For instance, group capping allows you to put multiple LPARs together and set what is essentially a defined capacity or an upper limit of MSU utilization to be shared between multiple LPARs within the group. Now, that works very, very well. The problem with group capping in IBM's terms is that group capping doesn't really pay attention to the relative importance of the work that's running on the LPARs. And unfortunately, one of the things that tends to happen is that one or more LPARs ends up being capped because you've hit the group capacity limit. Then all adjustments tend to stop until that 4-hour rolling average falls down below your group capacity limit. Now, this is an important consideration, because when that stops, that means you could have a couple of LPARs that are running a high level of low importance work. Again, group capping is not aware of the importance of the work, and the rest of the LPARs will not receive any adjustments. Now, what BMC tries to do is we say, what you need to do is to get your capping right in the first place. And it's difficult to do because the fact of the matter is if you set your caps too high, you're not doing anything. But if you're not aware of the importance of the work and you cap too aggressively, you're going to end up delaying work that really shouldn't be delayed in the first place. What BMC recommends that you do is have the capability of being able to take what would be static, flatline, defined capacities, and with importance awareness of the work, being able to adjust them to exactly where the work is running. And BMC can offer some solutions. Talk to us about it if you're interested in this sort of thing. in ways that we will put some tools in place that will dynamically adjust those caps. So for instance, this is an example where we have 3 LPARs. Now each LPAR is individually capped at its own level. We can see that in the first example here that LPAR number 1, call that your production LPAR, was capped at a particular level, but because of a spike in the very high importance work, we are now capping that particular LPAR, and your most important work now is being delayed. At the same time, we have 2 other LPARs that are not even achieving what their cap is going to be. They have MSUs to burn, but we have no way at this point of taking advantage of those at the same time as we're delaying the work. And as we show in the example here, this was a max 4-hour rolling average of the 3 LPARs together of 811 MSUs, and yet we're still capping very important work. If you use intelligent capping, and this is one of the things that BMC can bring to the table, we can set what we call an MSU limit. Let's say 650 MSUs. Now that's 161 MSUs less than what you would have been paying under a static defined capacity, but with intelligent capping, we can provide those unused MSUs from LPARs 2 and LPAR 3 to LPAR 1 so that your high importance work is not being capped on the production work and you're using only the amount of MSUs that you need on your development and your test LPARs. So you can see there's some very great advantages to using intelligent capping as opposed to the out-of-the-box capping capabilities that are available from IBM today. What else is that going to do, however, is because we were able to go ahead and reduce that MLC, people always ask us if there's going to be a risk of being able to miss the SLAs that are associated with it. Intelligent capping not only allows you to put the MSUs where they need to be relative to the importance of the work, but we also take advantage of what is the importance of the individual LPAR. We said that LPAR A, B, and C have various levels of importance, but we can also tell intelligent capping that there is a minimum number of MSUs that need to be allocated to a particular LPAR in order to make sure that we are always going to be putting the MSUs where they need to be. And that's really what we talk about when we talk about intelligent capping and taking advantage of that type of technology in order to actively manage what's happening in your peaks at any particular time. Now, I said that's one approach. The other approach to actively managing your peaks is what we call consolidation of workloads. Now, we all understand the way MLC works today. In today's world, we have work that's running on individual LPARs, and as Jeremy talked about, it's the combined 4-hour rolling average that is going to be driving exactly what it is that we're working with. And what I'd like to do is kind of compare that to the distributed environment. The distributed environment is very, very flexible. The distributed environment utilizes something that we call a service-oriented architecture. Basically, you have a service consumer who's looking for data. Typically, that's your transaction systems, and a service provider, which would be your database systems. And somewhere in between, you have some sort of middleware that allows the communications so each of these can talk to each other. Now, very frequently in a distributed environment, the architecture of this environment says that you're going to be running your consumer on one platform, your middleware on another, and your service provider on something else. The mainframe environment does things a little bit differently, and that's just because of the way that the mainframe was built. On an individual LPAR basis, we tend not to have a whole lot of middleware. What we have is a service consumer, your transaction systems, that talks directly to the database systems. And those, of course, are spread out on the individual LPAR depending upon the relationship between your transaction systems and your database systems. And the result, of course, from an MLC point of view, is that all LPARs pay for all products. Now, there's other ways of looking at this thing that might be important. If we could provide the middleware, and this is one of the things that BMC does with a tool that we call the BMC Subsystem Optimizer, this gives you the ability of separating your transaction manager, which is an MLC product, from your database system, which is another MLC product. And as you're going to see, that's a significant way of reducing that MLC. Now, you may remember this diagram that Jeremy talked about a little bit earlier. Remember, in that case, IMS may have been only 4% of the MSU contribution in his environment, but was representing 29% of the bill. This is also true of your other MLC products, such as CICS and DB2. Each one of these can contribute a significant amount to that MLC bill. So consider this particular scenario. If you're talking a 2 LPAR environment that's running, for instance, a KICS DB2 type of an environment, your peak 4-hour rolling average for LPAR 1 was 120, and your peak for LPAR 2 was 150. That's 270 MSUs, and that's what's being charged for not only CICS and DB2 because they're contributing to each other's MLC, but also for ZOS. We see in this case, however, that CICS by itself is contributing a very small amount of the MLC, and yet that peak of 270 MSUs is what we like to refer to as green space. Green space, or the green zone savings opportunity, is the difference between what you're paying for a product as opposed to what CICS is actually contributing. And we can see in this case that CICS is contributing significantly less than even 100 MSUs to that particular environment. Now, if we took that type of an environment using the subsystem service model, the same one that the distributed systems use, and if we were able to go ahead and put CICS out there on an LPAR all by itself, that means now that CICS would only be charged for 90 MSUs as opposed to the 270 that it was being paid for, which is a 66% savings on CICS. And by separating KICS and DB2 from each other, now DB2 is going to have a 30 MSU reduction, or 11% savings, or an overall 30% MLC savings. So think about that for just a moment. If you had the capability of separating your transaction manager, CICS, from your database system, your service provider, in this case DB2, you have an opportunity in this case of really saving some very, very significant MLC. So as I said, managing the peaks. I've talked about a number of different things such as tuning your workloads, moving your workloads, capping your workloads, and being able to separate out in order to be able to move things around. This is action. And of course, people always say action means change, and change introduces risk. But what we recommend that you do here at BMC is use intelligent and sophisticated tools to enable that change and minimize that particular risk. And our message to you from BMC is, if you haven't done so already, take a look at our intelligent capping and subsystem optimization tools, because they can achieve both of those goals. Now, I talked about a little bit earlier, controlling the budget is a very important thing to do as well. Controlling the budget is important because every MSU counts. You need to be comparing that against the budget on an ongoing basis. As you go through this entire process, what you need to do is to be looking at what you're doing, what you're paying in terms of your MLC bill, as opposed to what the budget happens to be. Compare this against what you're planning on paying. Are we doing better than we're expecting to do, or have we seen some changes that means that we're going to be paying more and we need to do something more about it? The important thing to be able to do is to compare that against what we know we're going to pay, what we expect to pay, against what we're actually paying. Is our current usage cost actually comparing, and is that actually relative to what we plan on paying against it? And what is our projected total cost against the end of the year? Now, Cost Analyzer will give you that same capability. Look at what we're paying, and are we looking towards being able to project out towards the end of the year? Are we going to be meeting the budget? Now, of course, nobody gets fired for having met the budget. And, of course, everybody is going to be interested, and you will get kudos, however, for being able to go underneath the existing budget. The problem is if you do exceed your budget, now people's jobs are at risk, and this is the sort of thing that you need to be aware of well ahead of time in order to be able to take those actions that we need. So controlling the budget, as I said, is extremely important. What you spend today is going to be affecting the budget by the end of the year. And again, this is what people are going to be graded upon by the end of the year. Knowing what's going to happen is really half the battle that we're going to be dealing with. Taking action is important, understanding what's driving MLC, but being aware of what do we need to do in order to stay within budget before the end of the year. And as I alluded to a little bit earlier, taking care of things, I talked about R4B4. R4B4 gives you the capability of being able to get your MLC budget down to the point that you are being prepared to negotiate your next IBM contract. Now, the last thing that I'm going to talk about, and I talked about a little bit earlier, is tracking your success. As I said before, in IT, we as IT professionals don't tend to be very good about advertising our own successes. The cost optimization process not only is an iterative process, but as I said in the budget processing, we need to be able to compare against success. But it's also very, very important to track what we have been doing and make sure that our management knows exactly what it is that we're trying to do and how well that we're managing. Because remember, the people who are paying the bills are the ones who are going to be interested in what we as IT professionals are doing in order to manage those bills. So what we need to do, of course, is to be gaining that visibility and making sure that our leadership has the commitment that not only are we managing the bills, but they knew exactly who it is who's doing that. I won't go into that a whole heck of a lot more, but just in summary, I want to just kind of reiterate the types of things that I talked about. It's a 5-step process. The first step, as I said before, cost transparency. Know what it is that you're paying for your individual MLC products. Step number 2, analyzing the peaks. Know why it is that you're paying what you're paying for each of those MLC products. Step number 3, take action when we see what it is that's driving that MLC bill, and take action so that we can drive down those peak flour rolling averages. The things that we can do in order to take those down: rescheduling work, taking it out of the peak; tuning work that cannot be taken out of the peak; capping unnecessary work, or even moving that work out of the peak someplace completely different so it's separated from other MLC products. Step number 4, manage the budget. Compare what you're paying against what you actually are expecting to pay. Understand how you're doing against the budget, because remember, the last thing that we want to do is exceed the budget. The first thing that we want to do is do better than what it is that we're paying on the budget. And finally, track your successes and publicize your successes. Make sure that everybody knows what it is that you're doing in the first place, so we know that we have some success and we gain credit for the kinds of work that we're actually doing. So all of that said, I'm going to turn this back over to Jeremy. So Jeremy is going to give you a little bit more information on how to take advantage of some of the newest pricing models and be able to move those into the iterative process that I just talked about. Jeremy?
Thank you, Wayne. And as Wayne mentioned, the third secret is understanding IBM's newest MLC pricing models. Much like the various tax forms that are out there, IBM has a number of MLC licensing structures to choose from. On their website today, you'll find multiple types of workflow license charge structures, with the newest being country multiplex pricing and container-based pricing, which we'll now take a look at. Country multiplex pricing is kind of like filing your taxes jointly, in that it combines the MSU peaks from multiple CPCs to calculate the rolling 4-hour average. The benefit here is that you get to higher MSU counts, which, because of how the tiered structure works for MLC pricing models, could be lower incremental cost per MSU. Additionally, each version of a product will be charged as a single version within a product family. Now, on the surface, this all seems pretty straightforward, and it does add some flexibility, but it's important to keep in mind that it was built for growth and that there's a baseline upcharge that is calculated to ensure that your MLC cost doesn't go down because of moving to the model. The baseline has 3 pieces: the MSU base, or the average MSU peak over the past 3 months; the MLC base, or the average billed MLC over the past 3 months; and an MLC base factor, which is a normalizing factor for the upcharge. Let's take a look at an example. Here we applied country multiplex pricing to DB2. And in this particular month, DB2's peak rolling 4-hour average was 3,500 MSUs across all the CPCs. When we moved to country multiplex pricing, the MSU base was calculated at 3,000 MSUs. So that's where our starting point was. The MLC base was 211,000, and the resulting MLC base factor was 2%. Now, when it came time to calculate the monthly bill, a baseline upcharge of 4K was added, and that was a factor of the base factor of the base MSUs, the MSUs, and then the MLC base factor of 2%. Now, in this equation, before you move to country multiplex contract, you actually have control over the base MSUs, and that effectively means you have control over the MLC base and base factor. Driving them down prior to moving to this model is to your advantage. And the phased approach Wayne just walked you through can help you save a lot over the course of your country multiplex contract. So once you move to the model, our cost analyzer for Z Enterprise Solutions supports country multiplex pricing completely. Here you see country multiplex applied to DB2. All the MSUs from both CPCs have been added together to calculate the MSU count, and the base factor added in for the cost calculation for the product family. If we drill in, we can see the MSU contribution from each CPC. And from here, you can drill down even further into the individual LPARs of the CPCs, or even down into the workload types that are running on each CPC or within each LPAR. That way, you can see where the cost optimization efforts could yield some results. Lastly, let's talk about container pricing, and this is IBM's newest pricing model. Containers are, in their own words, simplified pricing for qualified solutions. Containers are workloads that are priced separately from other workloads and thus have no impact into existing workload cost. Again, like with country multiplex, the goal here is the MLC will not decline as it is built to promote growth on the mainframe. Containers come in 3 different flavors: application development and test solution, which is a standalone pricing for dev and test workloads; new application solution, which is for approved new workloads that aren't currently running on the mainframe; and a payments pricing solution, which is a per financial payment pricing metric. Now, these workloads can run on dedicated LPARs or be co-located with existing workloads within your environment. Some key things to think about when it comes to containers is size and cost. Let's start with size. The size of a container, as they shared at the last Share conference, is based on a 3-month average peak MS utilization of the workload that will be going to a container. In this example, even though the LPAR peak occurs on the 14th, the workload peak actually occurs on the 2nd and is 115 MSUs. Now, for simplicity, we'll say that 115 MSU was our average for the 3 months. One of the advantages from the test dev container is that it's allowed to grow up to 3x of the original value without impacting your MLC. This gives your test and dev workload plenty of room to grow. The cost of the container is calculated in a similar manner. It's based on the average MSU contribution at the peak rolling 4-hour average over the course of 3 months. So driving down the value or the contribution at the peak while ensuring that your container workload sizing is sufficient is important before moving into container-based pricing. Now, additionally, as I mentioned before in how MLC was calculated, I said there was LPAR peaks and workload peaks and product peaks and how they all could differ. If the MSU value for the containers will be subtracted from the MLC calculations, it's important to know what that does to the other workload peaks. In this example, my standard workloads, when containers are included, had a peak on the 22nd of about 175 MSUs. However, after subtracting the container from the workload profile, I see that my standard workloads now have a peak on the 15th of roughly 225 MSUs and dramatically reduces what I was expecting to save. So in summary, traditional MLC is hard to calculate. Country multiplex is good and it takes advantage of those higher MSU tiers, which will eventually mean to lower incremental cost per MSU, but keep in mind that you'll be locked into a base country multiplex charge. Containers are great if you're planning on significant workload growth, especially on the test dev. But keep in mind that how you're sized and the amount you'll be charged is based on your existing utilizations, and you want to make sure that the results will be what you're expecting. Lastly, it's always a good idea to examine and optimize before moving to a new pricing model. And as Wayne mentioned, we have our R4B4. Examine that rolling 4-hour average peak before you go into a new contract. So there are 3 secrets to driving mainframe success. The first, understanding how MLC was really calculated. The second, taking an intelligent and phased approach to managing MLC. And lastly, understanding the newest pricing models and how they can work for you. And with that, I'll open the floor to questions.
Thanks, Jeremy. So before we get started, we have had a couple inquiries about the slide deck. So if you joined a little late, just want to remind you that you can download a PDF version of the slide deck by clicking on the Event Resources tab, or it's like a drop-down menu on the left side of your screen, and you can do that right from the platform without having to leave the webinar. So let's go to the first question. First question is, wouldn't it be even more intelligent to manage the CPU demand creating the peak, to proactively manage the MSU growth rather than wait for a limit to be hit before taking action? Any plans to offer that capability?
Well, Janine, this is Wayne. I think I can take that question. In fact, that's a really excellent question in terms of being able to manage the demand before it actually gets to the peak in the first place. And that kind of refers back to one of the things that I mentioned a little bit earlier, which talks about, first of all, being aware of what it is that's driving the activity in the first place so you can focus the efforts on what's going on. Because obviously it's the increased demand that is going to be driving up the 4-hour rolling average in the long run. And of course, when you understand who it is who's driving that activity in the first place, and one of the things that I suggested that you do is be aware of those and start taking tuning activities to look at those individual applications. Now, without actually talking about individual products, I know there's a lot of things that are out there in the marketplace today that allow you to get a detailed look inside of applications while they're actually running, and that can either be at the code level, whether that be a COBOL or assembler or those types of tools, or looking at the things like DB2 SQL. It's real important to understand, be able to look at those things and take advantage of those tools, because if you can manage the work that's going on in the systems, then of course it will give you a really good opportunity to be managing the growth of those workloads even before it gets to those peaks. So it's a really good question. Thanks for giving me the opportunity to expand on that one just a little bit.
Okay, next question. What are the typical savings people get when they're using the whole life cycle approach?
Jeremy, you want to take that one?
Sure, Wayne. You know, the typical savings we see now, it varies from every system across the spectrum, but we typically see some 5, 10, up to 20 and 30% savings by using the full life cycle approach.
Great. Does ICAP require me to use MainView?
Okay, I think that one's one for me. Well, the fact of the matter is I didn't talk about it a whole lot, but ICAP itself, and obviously so you have somebody here who's familiar with that particular technology, ICAP was actually built using BMC's MainView architecture. Now, what that means is that no, you do not need the MainView products themselves in order to use intelligent capping, but it does require using the MainView architecture in order to enable that particular technology. And you'll find that there's some real big advantages to being able to do that, because this is the heart of the intelligence that is what intelligent capping works off of in the first place.
Okay. Is Subsystem Optimizer rerouting my transaction?
No, actually,
go ahead.
Go ahead. Actually, what we're doing with Subsystem Optimizer is intercepting the data request and routing it to the remote DB2. So the transaction stays on the service consuming LPAR, and only the data request is routed over to the service providing LPAR.
Okay. We currently track our 4-hour MSU on one report by 15-minute intervals, and on another have CPU use by job or task by hour. Would you think I should bring the hourly report to the same level of reporting detail? So one's by 15-minute intervals, one's by hour.
Wow, that's an interesting question. Well, I would say that really would depend upon how you're using those reports in the first place. Now, keep in mind that in terms of MLC reporting is being done on a 1-hour interval to begin with. So, of course, that's probably the way to look at it when you're looking at things in terms of what you're going to be paying for your MLC, because again, it's that 1-hour average that goes into the 4-hour rolling average. It's going to determine what that peak hour is during that particular time frame. Now, if you've got a report that's showing a 1-minute interval, that's a really great way to go ahead and look at it, because it gives you a much finer level of detail. So I think probably the answer that I would give you is in terms of tracking the utilization by individual workload, I think it's probably a good idea to go ahead and keep things on that 15-minute interval because it gives you a lot more detail into what's driving that 4-hour rolling average in the first place. In terms of simply reporting your MLC utilization and what's actually going to be driving the bill, go ahead and continue to look at the 1-hour reports. So interesting question. I thank you for bringing that one up.
Okay, here's one on Cost Analyzer. Does it give me recommendations for where to save money, and how does it do that?
Well, I guess I'll take
it. Actually, go
ahead. We're stepping on each other here. Jeremy, you go ahead. We'll take some turns here.
It provides the vehicle for you to examine your environment and your MLC costs, MSU utilizations as a whole. And so you can go in and find where the best places would be to apply cost optimization efforts. Additionally, it provides you with a vehicle to model out the effects of what those cost optimizations efforts would be. So it doesn't point out where to apply the pressure, but at the same time it gives you that visibility and optics in to know where that pressure should be applied.
Okay. I don't see any more questions right now. I do want to let you guys know if you are looking for information, you can go to the BMC website, www.bmc.com/MLC. Well, actually, there might be a little more to it. There you see it on the bottom of that slide. So be sure to check that out. Lots of great information here to save you money. I want to thank everyone for attending today's webinar, and I especially want to thank Jeremy and Wayne for sharing their expertise with us today. Later this week, watch for a follow-up email. It will contain a link to the recording of today's webinar. That concludes our webinar. Thanks again, and have a great day.